Section 10.1 is about exponential functions. So this is an example of an exponential function. If a is greater than 0 and a doesn't equal 1, then the exponential function with base a is denoted f of x equals a to the x. So first off, let's check a couple things. So why does a have to be greater than 0? Well, if a was negative, like let's say we had negative 2 to the first power would be negative 2. Negative 2 squared would be 4. Negative 2 squared would be, cubed would be negative 8, right? We switch between negatives and positives, so we can't have a be negative. And if a was 1, 1 to the 1 is 1, 1 squared is 1, 1 cubed is 1, that'd be a very boring graph. So here I have f of x is 2 to the x, so I've got 2 to the first power, which is 1. Sorry, 2 to the 0 power, which is 1. 2 to the first power, which is 2. 2 squared, which is 4. 2 cubed, which is 8. And then I also have like negative exponents as well, because remember, 2 to the negative 1 is 1 over 2, so a half. 2 to the negative 2, because we don't like negative exponents, is 1 over 2 squared, so 1/4, right? So this is an exponential function. So here are some characteristics of an exponential function. So first off, the points negative 1, 1 over a, 0, 1, and 1a are on the graph. Well, why is that? Let's say I had f of x is 3 to the x. 3 to the negative 1 becomes 1/3, which is 1 over a. 3 to the 0 is 1, because any number other than 0 to the 0 power is 1. And 3 to the first power is just 3 itself. If a is greater than 0, it's an increasing function. If a is less than 1 but greater than 0, it's a decreasing function. The x-axis is our horizontal asymptote. I can never have a negative y-out value. Our domain is from negative infinity to positive infinity, and our range is from 0 to infinity. So let's solve each of the following, except this one. I have f to the negative 1 is 2 to the negative 1, which is 1/2. F cubed is 2 cubed, which is 8. And when you get a fraction, like I did right here, or a decimal, that's when I would definitely recommend you plug those into your calculator. So let's graph the following and state the domain and range. So I have 3 to the x minus 4. So that means my graph has been shifted down 4. So let's pick some x values. Let's pick some easy ones. Negative 1, 0, 1, 2. Why not? So if I have 3 to the negative 1 minus 4, that is 1/3 minus 4, which would be negative 3 2/3. If I have 3 to the 0 minus 4, that's 1 minus 4, which is negative 3. 3 to the 1 minus 4 would be 3 minus 4, which is negative 1. And 3 squared minus 4 would be 9 minus 4, which is 5. So now I have some points that I can plot. So I have when x is negative 1, y is negative 3 2/3. When x is 0, y is negative 3. When x is 1, y is negative 1. And when x is 2, y is 5. I'm going to have a new asymptote here because my graph originally had an asymptote if I had 3 to the x. This graph would have an asymptote at y equals 0. Now I have an asymptote at y equals negative 4 because my graph was shifted down 4. Here's our asymptote. So this is my graph of my exponential function. My domain is all real numbers. My range goes from -4 to positive infinity. Next, let's graph 1/2 to the x. This one's going to be a little trickier, and this one will be decreasing, and I'm going to show you why. So let's take a lot of space. -2, -1s, 2. Okay. If I have 1/2 to the 0 power, that is 1, right? Any number to the 0 power is 1. If I have 1/2 to the first power, that's 1/2. If I have 1/2 squared, that's 1/4. See, my numbers are getting smaller. If I have negative exponents, remember, if I have 2 to the -2, that becomes 1/2 squared. We have to do the same thing with fractions. So let's look at this. If I had x was 2, I have 1/2 to the -2. That becomes 1/4, because we have to square it, right? 1/2 to the 2, I'll leave it like that. That's 1 divided by 1/4, if we rewrote it, because this means division. Well, when I'm doing division of fractions, I keep the first fraction the same, change from division to multiplication, and flip the second fraction. So my answer is 4. The same thing's true for -1. If I have 1/2 to the -1, that becomes 1/1/2. So 1 divided by 1/2 is 1 times 2/1, which is 2. That's why if I have an a between 0 and 1, it's a decreasing function. So when x is 2, y is 4. When x is -1, y is 2. When x is 0, y is 1, 1/2, 1/4. And because my graph wasn't shifted vertically, my asymptote is still at x equals 0. So my domain is all real numbers, and my range is from 0 to infinity. Next, let's talk about solving exponential equations. If I have a to the u equals a to the v, then u equals v, right? That has to make sense. And let me do a simple example for us. If I have 2 to the x is 4, what's x going to be? If I have 2x is 4, 2 to the what is 4? Well, that's 2, right? So I have 2 squared is 4. Well, what's another way to rewrite 4 as an exponent? 2 squared is 2 squared. That's true. So when it comes to writing these problems, we want to make sure that we have both sides of the equation as an exponent with the same base. So if I have 2 to the -x equals 16, 16 is 2 to the 4th. That means -x equals 4, so x is 4. -4, right? Because I divided by -1. Let's try that again. If I have 3 to the 2x minus 5 equals 9, I can rewrite 9 as 3 squared. So I have 2x minus 5 is 2. I add 5 to both sides. 2x equals 7. X is 7 halves. Let's try this again. If I have e to the 2x is e to the 5x plus 2. E, just so you know, is a constant. We're going to talk about it more in section 10.5. But for right now, just know it's an irrational number. But because they have the same base, I can use this property. 2x is 5x plus 2. I subtract 5x from both sides. And I get 3x equals 2. X is -2/3. Next, I have e to the x squared is e to the 3x times, how could I write this so that it's not in the denominator? Well, remember, if I have 1/2 squared, that's the same as 2 to the -2, right? So I could undo this, so I'll have e to the -2. Now I have, when we multiply exponents, we add them. So I have e to the x squared is e to the 3x minus 2, because these have the same base. So I have x squared equals 3x minus 2. I'm going to move everything to one side of the equation. So I have x squared minus 3x plus 2. And I factor this. Okay, what are the factors of AC that add up to b? Well, that's going to be negative 2 times negative 1. So I have x minus 2. X minus 1 is 0. X minus 2 is 0. X minus 1 is 0. See, we're so good at factoring by now. X is 2 and x is 1 are my solutions to problem 2. So e is a real number and it's not a variable. E is 2.718 ... It's an irrational number, meaning it can't be written as a fraction, and it goes on and on and on forever. And if you really want to know how e is found, it's found by taking 1 plus 1 over n to the n, and as n increases, it approaches e. So as n gets bigger and bigger and bigger, it gets closer and closer to 2.718.